Hello, math students. Welcome back to our module called Integer Exponents and Scientific Notation. This is lesson 2, and it is called Multiplication and Division of Numbers in Exponential Form. Our goal for today we will learn how to multiply numbers in exponential form. The question that I want you to think about is, what rules can you determine for multiplying numbers in exponential form? All right, so let's start this lesson off with things to know. Under the things to know section, we first start out with multiplying numbers with the same bases. When multiplying numbers with the same bases, you add the exponents. So the only time that you can actually add exponents is if the base is the same. So for example, if we have 8 squared times 8 to the 7th power, because this is an 8 and this is an 8, then all we have to do when we're multiplying them together is add the bases. And the way that we prove that this works is by looking at it in expanded form. So 8 to the 2nd power times 8 to the 7th power equals 8 to the 2nd plus the 7th. And when you add those, you get 8 to the 9th power. And now we're going to prove it. So why does this work? Write the powers in expanded form and see what you have. So we started out with 8 squared, 8 times 8, times 8 to the 7th power, 1, 2, 3, 4, 5, 6, 7. That's 8 to the 7th power. And when you're multiplying them all together, it becomes one big group of 8 to the 1, 2, 3, 4, 5, 6, 7, 8, 9th power. So as you can see, when you expand them out and actually see what you're working with, you actually do have 9 eighths being multiplied by each other. Okay? So again, let's go over it again. When you have the same base and you're multiplying, all you have to do is add the exponents. Okay, so then the next one that we need to talk about is raising a power to a power. Okay, remembering that a power includes a base and an exponent. So that means that you have a power and you're raising it to the power of another exponent. This means taking a given power and raising it to another power by applying a second exponent. So for example, if we had the base of 2 raised to the 3rd power, then we're taking all of that and raising it to the power of 6. So what that means is your base now becomes 2 to the 3rd power, and we have to multiply it by itself 6 times. So we have 2 to the 3rd times 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 2 to the 3rd. And if you count them, those are 6 times. Okay? If we want to see exactly what that means, it means 2 to the 3rd is this little group. So we have 2 times 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 2, because there are 1, 2, 3, 4, 5, 6 times, because that's what that exponent tells us to do, and what's inside is what the base or the power, the initial power, told us to do, which is the base of 2 multiplied by itself 3 times. So then what you have to do is count how many 2's you have. So essentially we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this whole thing, or just this part of it right here, would be simplified to 2 to the 18th power. So when you raise a power to a power, you keep the base the same and you multiply the exponents. So check it out. We have 2. So the 2 stays the same because that's our base. But what is 3 times 6? 18. And you can see it right there, proven in expanded form. Okay? So that's pretty simple. So multiplying numbers with the same bases, as long as the base is the same, you add the exponents. When you're raising a power to a power, when it looks like this, you keep the base the same and you multiply the exponents, and that's how you solve that one. Okay? Remember, you cannot combine powers that do not have the same base. So this is a 2 and this is a 3. Because the bases are not the same, you cannot combine the exponents at all, because 2 to the 5th power means 2 times 2 times 2 times 2 times 2 times 3 to the 3rd power, which is 3 times 3 times 3. And you cannot combine them because their bases are not the same. So to simplify this back, what you see is 2 to the 5th times 3 to the 3rd. Now, obviously, you could multiply these numbers out and get standard form, but as long as we're working in exponential notation, the only way that you could do this is exactly the way it's already written because your bases are not the same. Okay, so that's very important to remember that. All right, so then the next thing that we're going to talk about with our notes is what happens when you're dividing numbers with the same bases. Well, you actually follow the same rules because it makes sense. When dividing numbers with the same bases, you subtract the exponents. So when you're multiplying numbers with the same bases, you add the exponents because multiplying and adding are relatives of each other. Well, the same thing goes for dividing and subtracting. They are relatives of each other. So this is how we would set it up. If you have 9 to the 6th power divided by 9 to the 5th power, your bases are the same. So all you have to do is 9 to the 6th power minus 9 to the 5th power, which gives us 9 to the 1st power. Okay? Again, why does this work? Well, the best way to prove it is to expand out your powers. So write the powers in expanded form and see what you have. So 9 to the 6th power actually looks like 9 times 9 times 9 times 9 times 9 times 9 divided by 9 to the 5th power, 1, 2, 3, 4, 5. So that's 9 times 9 times 9 times 9 times 9. And then what you simplify is you're dividing it off. What is 9 divided by 9? 1. What is 9 divided by 9? 1. What's 9 divided by 9? 1. What's 9 divided by 9? 1. What's 9 divided by 9? 1. What are you left with? 1, 9. So it's 9 to the 1st power. So the best way to understand this is to think, what am I doing? And what you are doing is you are dividing. You are actually dividing each of those bases off until they simplify to 1. And then you just write what is left unsimplified, and that would be 1, 9. So that's 9 to the 1st power. Okay? So again, review what we did. 9 to the 6th power divided by 9 to the 5th power is the same as 9 to the 6th minus the 5th power, which 9 to the 6th minus the 5th power is actually 9 to the 1st power because you're just subtracting. Okay? So that's pretty cool. All right, one other thing that I want you to look at, and this is called something to ponder, and it's kind of important, but I want you to look at this because the pattern that you are going to see is kind of phenomenal. So this says 2 to the 6th power, which means 2 times 2 times 2 times 2 times 2 times 2, which equals 64. Now, watch what happens though. When I go down by one exponent, written out, it's 2 times 2 times 2 times 2 times 2, because there's only 5 of them, and then we get an answer of 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32, so 32 would go here, right? Then we go to this next one. I'm subtracting 1 from each exponent. Now I'm down to 2 to the 4th power, so I have 2 times 2 times 2 times 2, and 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, all right? And then I'm subtracting an exponent, so 4 minus 1 equals 3, so I get 2 to the 3rd power is 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, so this one would be 8, right? What do you think the next one would be? Keep your base the same, subtract one exponent, and we get to the 2nd power. So what does that mean? 2 times 2, which 2 times 2 equals 4, right? Okay, and then look at the pattern. Subtract one of your exponents, so I get 2 to the 1st power, which means 2, which equals 2. And now what happens if we subtract one more exponent? So if we take 2 to the 1st power minus 1, we actually get 2 to the 0. And when you get 2 to the 0, what you're actually doing each time you move down, look at what happened. So we had 6 2's, then we divided one of the 2's off, and it became 5 2's. Then we divided one of the 2's away, and it became 4 2's. We divided one of the 2's, and it became 3 2's. We divided one of the 2's off, and we got 2 2's. We divided a 2 off, and we got 1 2. So now if we take 2 divided by 2, what do we get? 1. So every time you get any number raised to the 0th power, then the answer is always 1, because you're taking that base, dividing it by itself, and you get a 1, and you're taking that 1 exponent, subtracting it by 1, and you get 0. So any number that is a base raised to the 0th power gives you an answer of 1 every single time. So what actually happened when you go from 2 to the 6th to 2 to the 5th power, you are actually dividing by the base. And we did that each time because this is 2 times 2 times 2 times 2 times 2 times 2. If we divide by 2, now we have 5 2's. After we have 5 2's, if we divide by 2, we then have 4 2's. After we divide by 2, we have 3 2's. After we divide by 2, we have 2 2's. After we divide by 2, we have 1 2, and then 2 divided by 2 gives us 1. So that's how we know that 2 to the 0th power is 1. Okay, so that's kind of cool. All right, so what you need to do right here is it says, try one on your own. Show me the process of going from 10 to the 6th down to 10 to the 0th power. And I want you to follow this pattern that we did up there, but your base this time is going to be 10. And you're going to show me that right here. Okay, and then I have one more thing that I would like you to do is now try this one, and it looks more complicated, but I think you can handle it. 2 to the 5th divided by 2 to the 4th times 3 to the 7th divided by 3 to the 6th, and then all of that happens 3 times. I know, it's very, very complicated, but if you go back through your notes and pay attention to those rules of what I taught you, bases are the same. When you're dividing, you subtract the exponents. Bases are the same. When you're dividing, you subtract the exponents. Then whatever you have left inside here has to be raised to that power, and you do it 3 times because that's what that power is telling you. Remember, if you get lost, you can always write the problem in expanded form. And remember, expanded form is when you write it all out longhand like this, so you can actually see what's going on. But I'm very eager to see who can handle this problem as a challenge. Okay? So let's review what this lesson was about. A lot of information, but definitely some fun math. Our goal for today is we will learn how to multiply numbers in exponential form, which we did. We also threw in division, so we actually did 2 things on there. The question that I asked you at the beginning of the lesson was, what rules can you determine for multiplying numbers in exponential form? We have several. When multiplying numbers with same bases, when dividing numbers with same bases, when raising powers to a power. So you're learning a lot of stuff. So just make sure that you go back through the notes and make sure you have them all written down. Okay, kiddos, that's all I have for you. I'll talk to you soon. Bye.